All right, good morning everybody. Welcome to Nixu's webinar on IEC 62443 security. And I am Matti Suominen. I am heading the Nixus product cybersecurity unit, and I've been working with the team quite a lot. So here today to share some views and thoughts from various client assignments and other places as well.
Yep. Hi everyone from my side as well. My name is Aleksandr. I'm heading our industrial internet business. And my daily job is mostly to talk with our most interesting customers and companies innovating in industrial automation and IoT space and figure out what is the next big thing in cybersecurity. So a couple words about Nixu, unless you already know us. Seems that cold air does its tricks.
For sure. Welcome to Finland. Yeah. This is how it always goes.
Plus 14 in the summer or so. But yeah, so a couple words about Nixu. So we are a cybersecurity services company with a bit more than 400 people serving clients in industrial automation, IoT, corporate IT, digital business fields. So anything you can think of in terms of cybersecurity. And so topic for today is strategy for secured and connected products in industrial automation space. And we wanted to choose this topic due to the fact that this is an emergent area. So there's a lot of innovation going on in industrial automation. Industrial products, components are being shipped out all the time and also being implemented in environments that are maybe traditionally not being so secure, or they haven't met to be secure. There's a lot of legacy in place, and now digital factory concepts, industry 4.0, basically industrial automation is connecting to the internet, and they're connected via different products. So today we're going to touch base on a standard that pretty much unifies the entire industrial automation industry, and some key points from product development perspective that we think would be good to take into account when developing new products.
Yeah, and it's definitely been something that's being talked about by many of our clients, especially in the industrial field, but also in other related fields where the standards doesn't necessarily apply directly, but they are using a lot of the same components and same requirements. So it's basically seems to be what is being talked about as far as cybersecurity and the industrial side of things goes.
Yeah, or even IoT. So talking industrial automation in general, or manufacturing, power plants, maritime, even aviation. There's a lot of influence going on from this standard. So before we jump into the theme itself, just a note. So please send your comments if you have any in the questions or chat functionality. So you have this tab somewhere most likely, or it's viewable as a window. So post your questions and we'll try to answer them during this meeting. We already took 3-4 questions that we will answer based on our campaign or post in LinkedIn. So we have received some questions, we have prepared some material. But if there will be any other questions arising, just please send them forward and we'll try to answer them as well.
Sure. And if it turns out we don't have time, which in 30 minutes often happens, we will definitely follow up with a blog post or another webinar or whatever might be the suitable format for that. So definitely, if there's anything on your mind, just send a question.
Yes. So let's jump into the topic itself, and to set the scene, let's have a quick overview of IEC 62443.
Yeah, the standard is a bit complicated because it has so many different parts, and when you see this kind of listing, it might seem daunting at first. So I'll give you the brief overview of what you need to know. So there's 4 different levels here that we are talking about, and we've colored them with different colors just to make it clear, because all the different colors are related together. So those are very logical groupings. So the blue ones are the general ones, and those are more about defining terms and such. So they are not part of the standard or the part of the requirement set as such. You wouldn't go to those to look for requirements into how to develop products. It's just to define the terms that we will be using later. On the second level, the green ones, at that point we are talking about more about operations at the plant. So for example, if you're running a power plant, that is intended for the people who are running the operations, who are setting up remote management, whatever they might be doing. It's more related to, let's say, standard IT management frameworks. Then the last two are the ones that are maybe more relevant and interesting for our topic today. So we have the system level and the component level. So the components are specifically the products and the individual pieces that turn into the whole big picture. And it talks about how to develop those. So what is the actual process of implementing them, but then also about what kind of requirements apply to the actual product. So that's been the part that is quite interesting. And once you start taking these components and you start putting them together into a larger system, that's where you go to the yellow boxes. That's the part of the requirement set that is about interconnection. So for example, networking between elements and setting up firewalls and network segmentation and so forth. So that's like the rough divide between these. And one thing I could mention is that the reason why this standard has been so popular and so talked about, especially during the last few years, is that the last level, the component level, the Redboxes, are actually fairly recent. So they've come out within the last couple of years. And at least from our perspective, that's when a lot of the interest picked up. Because now there is a clear list of requirements how you actually need to implement your components, what needs to go there, not on a high level, but actually on the level of this is a specific implementation you need to have. So it's very sort of actionable guidance to follow.
Yeah, and I mean, in many cases, it has been thought in a way that the green boxes or the policies and procedures are more of, as you said, cybersecurity management for asset owners, or if you have a production facility. So this is how you basically manage your cybersecurity, while the yellow box was more meant for system integrators, the ones that are actually developing and maintaining those big systems in those production facilities. And then you have, of course, as you mentioned, components for component manufacturers. But this is not as simple as it seems.
No,
there are some dependencies between those.
No, for sure.
Maybe
I mean,
a couple words.
If you think about it from this perspective, that if you are a vendor that is in the space where the red boxes mean something to you, so you are developing an individual component, you might be led to think that, well, okay, I just need to implement the product requirements for that, and then I ship it off, and that's the end of it. But unfortunately, if you think about the chain, how it goes, so your component will end up being part of a system. There might be any number of other components in that one system. So it might be a factory, for example, and there might be a lot of different kinds of components from different vendors that make up the whole factory. So obviously, whoever is putting together the factory itself needs to consider that they have requirements to meet, and your component needs to be able to support them in that. So it cannot be so that they find out, well, actually, for example, we cannot get a log trail out of this. So we cannot do logging and we cannot do monitoring because the component doesn't give us anything. Similarly for the green boxes, so now the factory is actually being given to somebody to operate. Now that person needs to be concerned about, let's say, remote access, for example. So how do they meet their own requirements? Well, obviously you need to go up the chain and make sure that all the components give you the tools and means necessary. So it's not really enough to just think about, well, this is my box, here's where I'm living, this is how my product needs to go. You have to think about what your client is actually having to fulfill.
I think this is the key part. Basically, the lower you go down this pipe in terms of being a component manufacturer, for example, the more you need to think about how the system integrator works, what are the requirements of the asset owner, how those should be met, and that should be incorporated in your products. And many times we already today see even that asset owners, so the production facility owners, they actually have some specific requirements on how they will operate, and then their decision on components will be based on how they will operate with those components.
Yeah, I mean, it's very natural. So if you're setting up something, you need to make sure that whatever you're using to set it up is actually capable of what you want to do. So you have to be, if you are in the component development side, you have to be aware of the downstream requirements coming to your way. So definitely make sure you understand also what's happening in that area. Jumping forward a bit on that, so we already talked about this as being a standard, and obviously some of these parts are more, let's say, concrete requirements than others. So some parts are more about defining things, others are more about using those definitions to set actual requirements. There are some parts highlighted here which you can actually certify for. So you can actually get a accredited body to look into your solution, decide that, okay, you are doing everything correct, and here you go, you have the certificate to prove that. And of course, increasing clients are starting to ask that, well, if I'm in the group of people who are operating, for example, I need to make sure that I'm buying valid components. Or if I'm building a system, I want to put it together using components that are also certified. So that then brings up the problem of, well, does it actually matter? Is there any reason to certify? Or, I mean, if you implement the things, if you implement access control from technical perspective, then you have access control.
Yeah.
So the security is already there. But how do you see it? I mean, is there a reason to go for actual certification, or should you just aim for some level of compliance on technical level?
It's good that we received this question from our post, because this is maybe the question that is asked most by at least people and companies I work with and talk with. And we've created some material here around that. So when it comes to compliance versus certification, there are, of course, pros and cons. You can just be compliant. You know that is good. You maybe have some papers that will showcase that is good, or there you have a stamp on it, basically, on your device. And this is usually, if you look at other industries, I mean, should you have some functionality versus do you need to have a stamp? It's actually quite usually defined by the market standard. So it's defined by your clients. And today we see that more and more clients actually require certification, although maybe not the majority yet, but it's a, how to say, trend, because instead of having 160 tailor-made security questions, you might just refer to the standard if you understand what the standard says, and therefore it's easy then to trust a partner that from cybersecurity perspective. So I've gathered a small table here from public resources on certification, and as you can see, a lot of companies have already certified some of their products. One interesting trend here is to mention that this 4-2 and 4-1 standards are quite recent in terms of being certifiable, and today we see that most of the certifications that have been acquired by companies are done during 2019. Of course, there's more and more coming, but last year was the year that kicked off the certification boom, so to speak, or certification trend.
But if you think about it, it also makes sense, because if you think about industrial products in general, so let's say we are talking about some device that you place into a secure factory. You know, it's protected by walls, chain link fences, guard dogs, armed guards. So traditionally, there hasn't been that much need for cybersecurity. You know, you don't so much care about access control. If somebody gets into the facility, then they are, by definition, already they got through all the security you have. So from that perspective, there's a lot of products out there that weren't really designed to be secure or even securable in the first place. So there's no easy way to go from we literally have nothing into let's build this into something. You have to keep in mind that even the sort of baseline requirements here are, in industrial context, already fairly good ones. So we are not talking about just having really like baseline, you need to document a little bit of something. You actually have to implement things. So the timeline from we have nothing and we have an install base of something very significant to, well, all of our products are actually compliant with anything or even close to compliant. It's not something you do in a week. It's not something you do in a month. It might be something you do in a year, maybe even several years in some cases.
Yeah, that's absolutely true. And also the fact that let's say that this trend of certification has taken off quite nicely. I think it's already a positive sign for the future. But also in terms of coming back to the question, comply versus certificate, it's how would I say? You have functional safety requirements, you have certification for quality that you need to obtain, and customers are expecting that. So of course the trend will be that this will be more or less, how to say, permission to play. So if you would want to have your products on the market, then sooner or later you will have to certify those products.
Sure.
And go ahead.
And I guess with all standards, that's how it tends to go. So initially it's more of a guideline towards implementation. You see maybe one or two vendors, you know, get there fairly early, and then it takes a while. So from the point of view of sourcing, if you're buying components, you don't want to limit yourself to that one component.
Yeah.
So initially it might be more like, we would appreciate if you have this, but we know that you don't, so that's fine. But eventually it gets to the point where majority of the market has that. So if you think about any quality standards from the past, for example, it takes a while for everybody to get on board, but once they are on board, there's no way to get to the market without that. Yeah. Nobody's going to buy your product that doesn't meet some really baseline requirements.
I think that one very interesting note here is that in order to obtain this requirement, so 4-2 is a requirement for, or is a certification for technical security requirements of a product, and then 4-1, so the one that's where you see all the crosses, that is a standard related to secure development lifecycle. And you cannot actually certify your product before you have certified your development lifecycle, which basically means that if you have this product certification, it also means that not only that the product is secure to a certain level, but also that you have capabilities in your development to make sure that you consider cybersecurity as it's actually defined by the standard.
And it makes a lot of sense too if you think about it. So we are talking about products with a long life cycle. We are talking about years, decades in some cases for many products.
Yeah.
So if you don't have the process of maintaining it, following the vulnerabilities that come out, generally understanding where the world is going, when you need to do some changes to make things right, just getting it right once, that's no longer enough. So just deploying a product that will be unsafe within a month is not really going to be a good thing.
Which with cybersecurity is a given. It's great that your product is secured when it comes out of the R&D cave, so to speak, the oven. But the fact is that there will be found vulnerabilities. It's highly likely that there are vulnerabilities that will be found that we just have to accept that we don't know that they exist today, and therefore we should have the capabilities to identify those and actually to do something about this.
Yeah, it's actually the uncertainty is interesting here, because on one hand we have to say that we don't know what's going to come out. So we don't know if 1 month from now there's going to be a huge vulnerability in some of the components we are using, right? So we don't know that. On the other hand, what we do know in practice is that there will be vulnerabilities in general, because the industrial side has been the leading cause of new vulnerability discoveries within the last couple of years. Yeah. Since IT domain is so explored already, it's so saturated with people looking into things, you are not finding that much anymore. But then you jump into the industrial domain and suddenly it's like, it's like Christmas again, and you start finding so much more. So even though you don't exactly know what's going to be vulnerable, what's going to be a problem, you can almost rest assured that there is going to be something for something. So you know that you need to be able to react, you just don't know react to what.
Yeah, and maybe also to move a bit forward with this whole certification. So one thing to actually keeping in mind that the product will be vulnerable, the product still should have some capabilities to protect itself, right? And this is quite nicely defined in the security levels. So when you are creating a product, when you're developing a product, before doing that, setting up a right ambition level is highly important, and that again hugely depends on how critical your product is at the end of the day. And therefore, just wanted to go through the security levels, which basically means that, or to put it in the layman's terms, so security level 1 is something we call in Nixu a toaster security. So making sure that there is no accidental breach. So not much is actually required, but idea is to avoid these accidental breaches comes with these mass attacks, so to speak.
But at the same time, do not mistake that for easy to achieve. So it's a different thing. So it is a sort of baseline requirement, but it's sort of like, let's say you are in car manufacturing. So there is a baseline security level that every car needs to meet, but that doesn't mean that the baseline is something that you can just build in your backyard.
Yes.
There's a lot of work that goes into meeting the baseline. So I think different to many other standards, this one is actually reasonably hard to to get right. Like it's not something that you just accidentally get right.
And then I think that it actually gets more difficult the more resource constrained device you have at the end of the day. So if you have a highly resource constrained devices, you may even forget about achieving, say, security level 3 or 4. That's out of the question. So it heavily depends on where you are and how critical is the product at the end of the day. But then moving forward with the security level 2 and 3, so I believe that, and Matti, please provide more input, but to my understanding, the security level 2 is more about capabilities to protect your device as well as detect if something actually happens. And then when it comes to security level 3, it's pretty much adding, say, continuous monitoring in place, basically making sure that if something happens, you are actually then able to do something about it.
Yeah, it's just basically increasing levels of skill and effort needed. So you have to know what you are worried about. So activities like threat modeling are the key here. What are we worried about? Are we worried about, you know, our product being placed in a public location that where somebody can just come and kick it without meaning to do anything useful? So that might be level 1. Are we going to deploy this in a military context where any disruption is going to cause loss of human life? Then we are maybe thinking about level 4.
Yeah.
If it's a power plant, you know, where a lot of money is lost, it might be somewhere in between 2 and 3, depending on what the context is and how much money is involved. But you shouldn't just set the bar at 1 or set the bar at 4 before you think, you know, who am I selling this to? What are they expecting? So at the end of the day, the buyer is in a way the one who sets the level of expectation, and then your product either does meet that or doesn't meet it.
Yes.
So if you do not understand very well who you are selling to and what they are looking for, then it's a guessing game that you are most likely not winning.
Yeah, I think that the whole point of this is that these security levels would be, in the most optimal world, they would be identified by your customer.
Yes.
So if a customer feels, or the customer risks are made so that they or set so that they need to have high assurance, high security, then a security level 3. Security level 4 is like military. I think we can forget about security level 4 unless you have some highly critical infrastructure in place. But even for power grids, I would say that security level 3 is like the maximum, more or less, to figure out. But it should be driven by customers mostly.
So should we move forward in the interest of making the most of our time?
Yeah, and actually the next topic is very interesting from the perspective of product strategy and how this actually affects the company overall. So we've created a very interesting, how to say, slide from the perspective of understanding what does this actually mean to your organization. Maybe Matti, a couple words there.
Yeah, there's a lot of themes that come up when we start thinking about this sort of topic. So you can see some of the key themes up at the top. So for example, remote management and access control are some of those themes that tend to come up more often than not. If you think about the requirements in general, you have some which are generic and I hesitate to say easy to implement, but they're sort of simple things. You need to have a log file somewhere. That's fairly trivial. But then there are some themes that, especially in the industrial context, tend to come up quite a lot. So talk about access control for a moment. Anybody who has worked with any kind of factories or power plants or what have you, it is very typical that the access control is, shall we say, not quite the same level that you would expect in an IT environment. It might be that everybody is sharing an account to everything, if there actually even is an account. So it might literally be that people just walk to the workstations and carry on and so forth. So these kind of themes are usually the ones that we tend to see going wrong in a way or so.
Yes, for example, things like from access control perspective, there was some. Yeah, so from access control perspective, I mean, the most important, I believe, thing when developing these, even from cybersecurity perspective, is to figure out that safety comes first. So if there's an emergency, you need to have access to devices, and period. How do you implement that in a secure fashion? For example. Yes.
For sure. But this is interesting in the sense that this creates a lot of challenges within the traditional industries, because obviously when the standard comes out, you have a lot of products that are already out there. You are either, you know, doing research on them. They are already almost ready, they might be close to release, or they might be something that have been out there for a couple of years and you're still very actively selling them. So it's not like you're starting from scratch when you implement these things. So that's a tricky one for a lot of companies. What if I already have a product that is being shipped and used widely? There's going to be 10 more years easily that it's going to be used in the field. And then let's say our access control is not really anywhere near to what it should be. So those are tricky ones for sure. The vulnerability management point is also a really good one, because that I think is a challenge for a lot of companies. So if you ever talk to anybody in the industrial field, there is an aversion towards updates, changes. You want to keep the factory running in a way. It's not so much about, for example, updating in real time every day. There's a new security update, let's go. If you think about your phone, so if I use my phone as an example, the moment this says that I need an update, I will update it. That's perfectly fine. That is normal to do. In this kind of context, not so much. There might be situations where the products have never ever seen an update. It might be available even. I mean, the vendor might even provide it, but does anybody actually apply it? So these are tough questions in these kind of situations.
And I think when it comes to the whole maintainability aspect, I think it's quite interesting to note that when it comes to updates, right? It's for us when you have a mobile phone, you just accept it. But if you have an update that goes to a facility, it needs to be verified first by the customer, most likely, before you even can do something about it. And now, which basically means that I think that from vulnerability management perspective, it also adds extra pressure for the component manufacturers and asset owners, due to this fact that if there's a critical vulnerability found, it will not be patched immediately, only just due to the fact that it will not be possible based on any of processes by the asset owner. So when it comes to the manufacturer or for a device vendor, it calls for fast, fast implication that there's a vulnerability, and of course having patches ready as fast as possible. But the actual actions to take, the first actions to take on site, is actually on the asset owners. Asset owner's responsibility. So there should be, a flawless or seamless communication between the two, which sometimes is established quite well, but we also see less good of an examples of that.
So a couple of points I can mention, because we are running out of time fairly soon. 30 minutes is never enough time to talk about anything interesting. But I can mention a couple of things that people usually find interesting. And basically, that is mostly about what tends to go wrong. So I think we are highlighting here some of the key points that are actually typically the problem areas also. So if we talk to vendors, I would say the most common areas that are not entirely right, but also the areas which are typically somewhat harder to fix. The identity access management is an obvious one. That is almost always a challenge. So how do you make sure that the right people get access to the devices, whether that's through remote connection, whether that's through on-site connectivity, just physically going to the device? How do you provision user accounts to maintenance personnel? How do you tell apart who is doing what, or even who is authorized to do what? Can I just walk to a device and start working on it? That's usually an area that is very challenging and can be tough to figure out in some scenarios. Then the remote connection is, of course, another one. So we are increasingly seeing more and more cases where we need to get data out from facilities. We want to deliver it to cloud, for example. By the way, cloud is not in the scope for the standard in the slightest, which is interesting. Almost all of these installations tend to have some kind of cloud component to them, but in this case, it is rather outscoped. It's just basically information flowing out, and that's about it. There's no specific requirements, so you need to supplement it with something. But that's usually one of those, setting up the connectivity in such a way that you can access it, you can deploy patches if needed, you can do remote maintenance. All these kind of business scenarios are something that people seem to be thinking, and a lot of businesses would like to jump on board.
Yeah, but I think that from the, from strategical perspective, when figuring out cybersecurity in products, one needs to approach it from strategic perspective in terms of what should there be, and it quite nicely defines. So you have external factors, which are regulations, you have standards, you have customer expectations or market expectations. And internally, you of course need to also evaluate what are your capabilities, because it might be just that although someone wants and there's a high need of cybersecurity and high level cybersecurity, you might just not have the competence, which also makes you reevaluate the cost of doing stuff. And those again have huge implications. Firstly, on device. So is it the more security you actually add to device, the more hardware you actually need on the device and more functionalities. But also the backend services, like would it be then security monitoring or PKI, for instance. The more higher level you go, the more granular access you need to have, the more you need to have, the more juice you need to get from your PKI.
So with that, unfortunately, we are out of time today. We are planning to follow this up with different kinds of ways. There's going to be blog articles coming out, and we might do another webinar on more specific topics later on. So definitely drop your feedback, how it went, and what kind of themes you would like to hear more about. So we'll definitely follow up on those later on.
Yes.
So thank you, everybody. This has been our webinar on industrial security, and hopefully you learned something new today, and hopefully a little bit more curious about what's going on in these themes.
Yeah, thanks a lot. And before we jump out, please add feedback after this session is over. You will receive a feedback request. So please enter that, and if there are any questions we can answer later on, let us know. Thank you.
Thank you.